All right, if you've never worked in a big company, you know the feeling, right? That support ticket queue, it's just this endless, overwhelming flood. So what if you could throw an entire AI team at it? And I'm not talking about some simple chatbot. I mean a really resilient system, one that's designed to think, act, and, this is the key part, never ever fail. So let's get into it and see how this thing actually works.
Okay, so before we can really get into the solution, we've got to understand just how big the problem is. I mean, every single day, support teams are basically fighting this invisible battle against a relentless, silent enemy.
And that enemy? It's just sheer ticket overload. It's this constant flood that can bury even the most efficient teams out there. But here's the crazy part. A huge chunk of these tickets, we're talking something like 80%, are just the same old routine, repetitive questions over and over again. That's a massive amount of noise hiding the really important problems. And this really breaks down the chaos, you know? You've got all those simple, repetitive tickets, password resets, that kind of thing, and they just create so much noise that they bury the truly critical issues, like, say, a major billing error. And then you've got the tech side. A lot of AI tools out there are super fragile. If their main API goes down, poof, the whole system just stops working. Plus, there are these huge privacy risks, where sensitive user data, think API keys, just gets logged by mistake. It's basically a recipe for disaster. So, the big question is, how do you fight back against this kind of overload without, creating a whole new set of problems? Well, the answer here is a hybrid approach. So let's talk about the solution. Ticket triage plus KB. So what does hybrid actually mean in this case? Well, this isn't just a single AI model trying to do everything. Think of it like a whole automated support desk, staffed with specialized AI agents. But, and this is the really critical part, it also has these simple, rule-based fallbacks. What does that mean? It means if the AI ever goes offline, the system doesn't just collapse. Nope, it just keeps on working. And that difference is just huge. You see, a typical AI system, it's completely dependent on an API. That's a classic single point of failure. Plus, it might just carelessly log sensitive private data. But this hybrid system is totally different. It's built from the ground up for resilience. It can work whether it's connected to an API or not, all because of its smart, rule-based logic. And it's got this built-in sanitization layer that protects user data before it even has a chance to be logged. Game changer.
So you're probably thinking, wait a minute, why not just use one of those huge, super powerful AI models to do everything? And that's a great question. The thing is, the architecture here is intentionally different. It's designed like a team, and for a very, very good reason.
Yeah, this really gets to the heart of it. Instead of one giant model trying to juggle everything, you have a whole team of specialized agents working together. The best way to think about it is like a factory assembly line versus one person trying to build an entire car from scratch, right? By giving each agent one specific job, the whole process just becomes way more efficient and a heck of a lot more reliable. And for a business, this approach pays off big time. For one, the workflow becomes way more predictable. And think about this. If something goes wrong, you're not trying to debug some giant, mysterious black box of an AI. Nope. You can pinpoint exactly which agent failed and why. And that makes the whole system so much more reliable, easier to maintain, and, at the end of the day, something you can actually trust.
Okay, so we've covered the what and the why. Now let's dive into the how. We're going to follow a single ticket step by step as it moves through this automated assembly line. So here's the team that makes it all happen. You've got 6 core agents, and each one has a very specific job. First up is the ingestion agent. Its only job is to read and understand the raw ticket. Then it passes it to the triage agent, which uses Gemini to figure out what the ticket is about and how urgent it is. After that, the knowledge-based search agent jumps in to find the right answers from the support library. Then you've got the draft reply agent, which writes the response. But it's not done yet. The critic agent comes in to review it for quality and tone. And watching over all of them is the supervisor agent, who basically orchestrates the whole process, making sure everything runs like clockwork from start to finish.
All right, to really see this thing in action, let's follow a super common support request. You know the one. A user resets their password, but something goes wrong and now they're locked out. This is like the perfect example of a Tier 1 ticket. So, first stop is the triage agent. It uses Gemini to instantly analyze the text, and bam, it correctly identifies this as an account access issue and slaps a medium severity on it. I mean, it's not a total system outage, right? But it's definitely stopping a user from getting their work done, so it's important.
Okay, next up, the knowledge-based agent takes that classification and immediately searches its internal library of support articles. And we're talking milliseconds here. It finds 2 super relevant documents that have the exact solution.
So now the problem is understood and the solution is found. The system then drafts a professional, super helpful reply. The entire process, I'm talking from the moment a user hits send to having a complete ready-to-go response, takes just a few seconds. Just think about the amount of time that saves compared to a human workflow. It's incredible.
But, what's happening behind the scenes is just as important as what you see on the surface. This system is constantly running some serious enterprise-grade safeguards. There's a PII sanitization layer to protect user data. It has a memory bank that tracks ticket history to spot bigger patterns. And of course, that offline fallback mode is always on standby. All of this makes sure the system isn't just smart, but it's also secure and unbelievably reliable. So, what does all of this actually add up to? Let's talk about the real-world business impact, because honestly, that's where a system like this really proves its worth.
And here it is, the headline number. This system can fully automate around 70% of all routine Tier 1 support tickets. Now that doesn't mean it replaces human agents. Not at all. It actually frees them up to focus on the really complex, high-value problems that truly need their expertise.
So let's break down that value. That 70% automation, that translates directly to a massive drop in operational costs and response times. That offline fallback mode, it's not just a cool feature. It's what guarantees business continuity. And the PII sanitization, that isn't just good practice. It's absolutely essential for compliance and data security.
And you've got to remember, this isn't just about handling the easy stuff. By getting all those routine tickets out of the way, the system makes sure that the really high-severity issues, the ones that can actually cost a business real money, like a duplicate billing error, those get identified and escalated to a human expert in seconds. Not hours, seconds.
Which kind of leaves us with this fascinating final question, doesn't it? We often think the smartest AI has to be the biggest, most complex model. But maybe for the real world, the smartest AI is actually the one that's designed with a backup plan. The one that's resilient enough to just keep working no matter what happens.